Friends, once again welcome back to Engineering Mathematics 2. Friends, so far we have discussed about the concept of a differential equation and order of a differential equation, degree of a differential equation, and how we are going to write down general solution of a differential equation, and what are the special characteristics of a solution, and how we are going to use a superposition principle effectively, right? And the solution of a homogeneous linear second order differential equation using an auxiliary equation, right? And suppose if the roots are real and equal, how we are going to write down the solution? If the roots are real and different, and if the roots are complex, how we are going to write down the differential equation, right? Along with these things, I have also given some graphical representation of superposition principle for the homogeneous equation. Was it clear? Right? If the roots are real and different, real and equal, right? Complex roots, how we are able to draw the graphs of a solution curve, right? So, along with these things, I have also made an attempt to give some physical interpretation, right, belongs to mechanical as well as electrical branches. And we have discussed about Newton's second law of motion, and examples about free undamped motion, right, and how we are going to obtain the solution of d square x upon dt square plus omega square x is equal to 0 along with the given initial conditions, right. So far we have discussed all these things, right. Now, yesterday I have solved one second order differential equation, right. I have also given the solution curve and along with that, today in this session I am planning to calculate maximum velocity and acceleration attained by the mass. That means how we are going to calculate velocity and acceleration, right, and how we are going to draw the response of an harmonic oscillator, right, and a solution curve of x is equal to a into cos omega t minus theta for various values of amplitude, frequency and period. It means how we are going to change the amplitude, right, or by changing the amplitude, right. So, you can observe the graph, or by changing the frequency, right, we can observe the entire graph, right, and how we are going to calculate period, right. So, this is the formula for the period. By using this formula we can calculate period, right, and sketch the graph of solution of an equation d square x plus 9x is equal to 0. Here capital D represents we know that d by dx, right. I am planning to solve one more similar type of equation d square x plus 36x is equal to 0 with the initial condition x of 0 is equal to 8 and x single prime of 0 is equal to 0. Also find period and frequency. Is it clear? I have already given the physical meaning of initial value problem, right. Here they have given x of 0 is equal to 8. What is the meaning of this and what is the meaning of initial condition? I will explain, and I am also explain how do we calculate period and frequency, right. And I am planning to give an interpretation of various graphs by changing amplitude, mass, spring constant. So, I have planned for all these things. So, according to our plan, now first we shall think about how do we calculate maximum velocity and acceleration, right. The maximum velocity attained by the mass will be plus or minus alpha into omega, right, which occurs whenever cos of omega t plus theta is equal to either plus 1 or minus 1. So, it means this is equal to either plus 1 or minus 1, and sin of omega t plus theta is equal to 0. Thus, the maximum velocity occurs when the displacement is 0, right. That is, I have already shown when displacement is 0. Yesterday I have shown diagrams along with the diagram, right. So, that is when the mass is passing through its equilibrium position, right. So, at equilibrium position we said that displacement is 0, right. Exactly in the similar way the acceleration attains maximum, right, or maximum values of plus or minus alpha into omega square with the displacement, right. Hence, the maximum values of acceleration and displacement occurs at the same time, but have opposite direction, right. Now, yesterday I have shown along with the diagram, is it clear, right. So, a response of a harmonic oscillator to initial excitation, is it clear, right. So, here spring is moving downward direction as well as upward direction, right. So, friends, solution curve is x is equal to a into cos of omega t minus theta. As I have mentioned, suppose if you type this command or this equation in GeoGebra, I hope you will get a curve like this, right. Then if you are planning to calculate amplitude, so you can calculate amplitude, and if you want to calculate a period, so you can calculate period, right. Now, as you know, this axis I have treated as an x axis and this axis treated as a t axis, is clear, right. And this is the solution of this equation, is clear. It means the solution curve represents like this, right. I have also calculated period, right. So, using this formula, is clear, or directly from this point to this point period can be calculated using GeoGebra software, right. I think here I have mentioned 2.8, right. So, period to complete one cycle. One cycle means from one position to it will moving downward as well as upward direction, as clear, right. So, for example, if I consider a mass position from this, it will move upward and it will come back to the original place, that we call it as an one cycle, right. So, we can represent all these things or we can calculate all these things, right. So, friends, here I am varying some parameters, right. Same graph, right. Solution of the spring equation d square x upon dt square plus omega square x is equal to 0. Just now we have solved mathematically, right. Now, here if I change, right, some parameters, how it looks like, right. So, suppose if you want, you can observe, right, amplitude becomes 0 and again it is increasing, right, downward as well as upward direction, is it clear, right. So, if you change one parameter, right, how it looks, right. Suppose if I change another parameter, say omega, right. Now, you observe omega is changing, right. I have given values in between plus 5 to minus 5, right. I hope graph is changing or we are obtaining more cycles. Now, exactly in the similar way, suppose if we change theta, theta is another parameter of the equation, right. Now, graph is moving, right. Now, we can observe all those things, and how we are going to interpret those graphs. In diagram, observe that the solution is a cosine curve with amplitude alpha, which is shifted by the phase shift, right. So, theta by omega. The number omega is called angular frequency, right. So, our solution containing omega, what do you mean by omega? Angular frequency, since it is the time rate of change of the angle omega theta minus theta at which the cosine is evaluated, right. The number of oscillations per unit time is the frequency 2 pi by omega. Friends, yesterday in the last session I have given how we are going to calculate cosine of omega theta minus omega t minus theta, right. The motion described by the solution of the spring equation is called a simple harmonic motion, right. As we know, it arises whenever a system is subjected to a restoring forces proportional to its displacement from equilibrium. Such oscillatory system occur in science and engineering, right. I have already given information regarding how such type of problems arises in engineering and science field, right. So, I am planning to consider one more a similar type of equation, right. So, they may ask, instead of asking solve an equation, sometimes they may ask sketch the graph of the solution of d square x upon dt square plus 9x is equal to 0. Now, whatever I have solved in the last session, so that is an general example, right. Instead of omega square, suppose if you replace some constant, say 9, right. So, how it can be obtained the solution of this type of differential equation, right. So, satisfying x is equal to 1 and dx by dt is equal to 6 when t is equal to 0. Friends, as usual, so we can obtain the solution here. Omega square is equal to 9, right. So, given equation as, right, it can be written in a symbolic form, is clear, right. So, as usual, you want to replace d by dt by capital D square plus 9 into x is equal to 0. So, this equation we call it as an symbolic form of the given equation, right. So, once we are able to write down in symbolic form, what is the next step? Simply I have to replace capital D by m. I will get an algebraic equation or auxiliary equation, what I have written short form AE, right. So, m square plus 9 is equal to 0, right. So, from this I can obtain the values of this equation, or I can obtain m is equal to plus or minus 3i. So, m square is equal to minus 9, therefore, m is equal to plus or minus 3i. So, therefore, solution is x is equal to a into cos omega t plus b into sin omega t, right. Friends, you may ask how we are going to write down this equation, right. Again, it is very simple. By using superposition principle, so we are able to write down this equation, because roots are complex, right. Here alpha is 0 and beta is equal to 3, right, I. How we are going to write down complex roots? Alpha plus or minus 3 beta into I, is it clear, right. So, alpha is 0, that is why I have not written e to the power alpha x into the bracket, is it clear, right. So, if you want to, you can write down e to the power 0 into t into the bracket, you can write down these two terms, right. And here they have given the initial conditions, is it clear. So, now I want to use the initial conditions. By using initial condition, is it clear, what is the first condition? When x is equal to 1, when x is equal to 1, when t is equal to 0, right. So, using that condition, I can find out the value of a, how we have calculated in the previous examples. Exactly the similar way, I can calculate the value of a. So, what is the value of a? I hope you will get 1, right. It is very simple. In the given solution, replace x by 1, t by 0, sin 0 is 0, cos 0 is 1, that is why we can obtain, or we will get a is equal to 1, right. Now, exactly in the similar way, we want to obtain b, or the value of b. How we are going to obtain? They have given one more condition, dx by dt is equal to 6 when t is equal to 0. Using this boundary condition, I can obtain the value of b. It is very simple. You can find out the derivative of this equation. You will get the derivative of this equation. Then you want to substitute these values and simplify. So, you will get the value of b, right. So, okay, we will get, or we can obtain the values of the arbitrary constants a and b. Then you can substitute those arbitrary constants in the solution, is it clear, right. This is a solution containing a and b as arbitrary constant. Now, I will replace a by 1 and b by 2. So, what you will get? So, you will get, therefore, x is equal to cos of omega into t plus 2 into sin of omega t, right. Friends, the same equation can be written down in this form, alpha into cos of 3t minus theta. Just now I told that phase angle 3t minus theta, is it clear, or cosine of 3t minus theta, is it clear, right. So, since a comma b, order pair a comma b can be written as a is 1, b is 2, order pair 1 comma 2, and alpha comma theta or its polar coordinates, is it clear, right. So, it means I can calculate alpha is equal to square root of 1 square plus 2 square, that is equal to square root of 5, right, is approximately equal to 2.2, and theta is equal to tan inverse of b by a, right. The value of b is 2, a is 1. If you want, you can write in 2 divided by 1, and after simplification I hope you will get 1.1 radians or approximately 63 degree, is it clear. It means mass will shift 63 degree, or I can say that mass will shift or mass will shift 1.1 radians, is it clear, or this is the value of phase shifting, right. So, theta by omega is approximately equal to 0.37, right, and you can calculate period, so is equal to 2 pi by omega, right. So, you can substitute the value of pi and we know the value of omega and we have to simplify, right. So, you will get 2.1, approximately 2.1, right. So, when we draw the graph, so you can verify whether you will get same values or not, right. So, this is the graph of 2.2 cosine of 3x minus 1.1, right. So, we know that it is representing no damping, is it clear, right. So, here I have calculated amplitude. So, what is the amplitude? Approximately 2.19. Friends, I am sorry whether it is clear or not, but I think it is it representing a 2.19. I have also calculated period, right, 2.08. It means it will tally with the theory, right. So, what I have calculated amplitude and period. Okay. Now, exactly in the similar way, you can take d square x upon dt square plus 36 is equal to 0. Here it is given that x of 0 is equal to 8 and x single prime of 0 is equal to 0. Now, I have considered another example. Now, exactly in the similar way, we can write down an symbolic form d square x plus 36 or d square plus 36 into x is equal to 0, right. Again, I have to replace capital D by m. I will get an auxiliary equation m square plus 36 is equal to 0, right, or you can obtain m square is equal to minus 36. Therefore, m is equal to plus or minus 6i, right. It is exactly similar to previous example, is it clear, right. I hope we can write down the solution. Again, roots are complex. Again, in this case alpha is 0, that is why a solution can be written x of t, it means x is a function of t, equal to c1 cos 6t plus c2 sin 6t, is it clear, right. This is the solution of the given differential equation, right. What it represents, as I have mentioned in the last session, spring is not stretched, right. Equilibrium position, mass is attached, in this case mass is not attached, right. Now, this red line is called equilibrium position, is it clear, right. So, when we start a motion, right. So, it is given that initially it is given that displacement x of 0 is equal to 8 units, is it clear, right. That is why I have considered 8, right, initial displacement, is it clear, right, and they have given initial velocity is 0, right. So, I have written same equation can be compared with the general equation, right, omega square is equal to 36, right. I hope you will get omega is equal to 6. Now, I have already write down the solution. Now, I want to use the initial conditions, x of 0 is equal to 8, right. Again, by using this initial condition, I can obtain the value of the arbitrary constant, is it clear. So, 8 is equal to C1 cos of 0 because t is 0, C2 into sine of 0, right. So, we know that sine 0 is 0, cos 0 is 1. So, therefore, I can obtain C1 is equal to 8, right. And suppose if I want to use another condition, then I have to differentiate the solution. X of t is equal to 8 cos 60 plus C2 into sin 60, right. So, if you differentiate, so 8 is constant, so you can keep as it is. Derivative of cos 60 is minus times of 6 into sin of 60. After simplification, I hope we can obtain minus times of 48 sin 60 plus 6 times of C2 into cos 60. Is it clear, right? So, now I want to use another condition, x single prime of 0 is equal to 0, right. I will substitute 0, right, and t is also 0. Is it clear? Again, as usual, sin 0 is 0. It means first term becomes 0. Is it clear? So, 6 C2 cos 0 is 1 is equal to 0. That implies C2 is equal to 0. So, like that, by using the initial conditions, so we are able to obtain the values of arbitrary constants, namely C1 and C2, right. The value of C1 is 8 and C2 is 0. Now, I will substitute these two values in the solution. So, what is the solution? So, this is the solution. C1 is 8. I will replace C2 by 0. It means second term becomes 0. So, what is the required solution? X of t is equal to 8 cos 60 is one solution of the given differential equation, or we can say that this is the particular solution of the given differential equation, right. Friends, in the hypothesis they have also asked us to calculate period and frequency. Is it clear, right. So, how we are going to calculate period, right. So, in the given equation containing some variables, I have already explained. So, it is containing t. T means what? Time, right. So, time in seconds. X means what? Inches. Omega square is equal to, or omega is equal to 6. How we are going to calculate period? As I have mentioned, now you want to use 2 pi by omega, tells the interval in which the cycle repeats. Is it clear? And we can calculate frequency by using this formula, 1 divided by t, that is equal to omega divided by 2 pi, right. So, what we will come to know from this formula? How many cycles over an interval? Is it clear? How many cycles over an interval? Now, as usual, from this diagram, spring not stretched, equilibrium position, motion starts. I hope we can observe the animation. Initially, they have given the displacement, say 8 units. Is it clear, right? So, by using this formula, I can calculate period is equal to t 2 pi by omega, right. So, pi value is known. I will substitute and simplify, and I can obtain approximately 1.047 seconds to complete one cycle. Is it clear? To complete one cycle, how much of time is required? 1.047 seconds, right. So, exactly in the similar way, I can calculate frequency, right. So, 1 by t or omega by 2 pi. Is it clear, right. So, again we want to substitute the value of pi and simplify. I hope you will get 0.955 cycles are completed for every second, right. So, I hope by using these two formula we are able to calculate period and frequency, right. So, when you draw the diagram or when you draw the graph, now you can verify. Is it clear, right. Now, I hope now you are observing a colored graph, blue colored graph. Is it clear, right. So, position of the mass starts from this point, right. Again it will move upward and once again it will come back to the original point. Is it clear, right. So, when you draw the graph of the motion of a mass, I hope you will get a graph like this in this form. Is it clear? Now, exactly in the similar way, you can calculate period, right. Now, period is approximately 1.04. Is it clear? And I have already calculated 0.95 cycles to complete one cycle, right. So, like that it is possible to calculate mathematically as well as graphically. Graphically means when you draw the graph using the GeoGebra, it is possible to calculate period as well as frequency. Is it clear, right? So, friends, I hope now you can draw the similar type of graph using GeoGebra, right. So, when you observe this graph, right. So, here mass is moving upward direction and downward direction, right. You observe this point, according to the mass, this point is moving on the curve, right, downward direction, upward direction. Is it clear, right? And t is fixed from 0 to 30 seconds. Is it clear, right? So, like that, so mass is moving upward direction, downward direction, right. Now, you can calculate the period, how much of time will take to complete one cycle. Is it clear, right? So, it starts from 0, right. I hope it will take this much of time to complete one cycle. Here we have calculated it requires 7.02 seconds to complete one cycle or one period. Is it clear, right? So, exactly in the similar way, if you want to, we can change the amplitude, we can change the mass, we can change the spring constant. Is it clear? By changing these parameters, so we can observe the graph, we can observe the frequency, we can observe and a displacement, etc. Right. I hope now I have changed the frequency. Is it clear, right? By changing the frequency, now you can observe, right, spring is moving and we have obtained more cycles when we compare with the earlier graph. Is it clear, right? So, I hope now you can observe, right, to complete one cycle or to complete one period, t is equal to, right. So, now it is showing 1.4 second. Is it clear? Or you can change on another parameter. Suppose amplitude becomes 0. Is it clear, right? Amplitude becomes 0. Now, point is moving on the t axis. It means there is no motion. Or you can change another parameter. Is it clear, right? So, I think I have changed k, spring constant. Is it clear? So, once again you will get more cycles, right. So, when we compare with the earlier graph, here we are obtaining more cycles and you can observe the time, right. What is the period? Period is 0.63 seconds. Is it clear, right? Now, we can observe all these things. Okay, friends, now we are able to draw the diagram and we are able to calculate period and frequency. Is it clear, right? So, exactly in the similar way, now I want to solve one word example, right. Now, in the earlier example, directly it is given that an differential equation with an initial condition, right. Now, in this example, they have not given an differential equation, right. Instead of differential equation, they have given some explanation, right, about the physical problem. What it is given that let m be a weight, right, with mass 1 gram, right, on a spring with spring constant 3/2, right. Let the weight be initially extended by a distance of 1 centimeter, moving at a velocity of 2 centimeters per second, right. So, they have given this much of information and they have asked us to calculate. What they have asked us to calculate? How fast is m moving at t is equal to 3. Here capital M means mass. Mass is moving at time t is equal to 3. We have to calculate, right. And they have also asked us to calculate what is m's acceleration at t is equal to 4. It means at time t is equal to 4, what is the acceleration of the mass? We have to calculate, right. So, what is m's maximum displacement from the rest position or what we say that equilibrium position, right. So, when does it occur? It means when it attains maximum displacement. So, we have to calculate, and finally they have asked us to sketch a graph of the solution. Is it clear? Now, we want to calculate all these things. Is it clear? Right. So, before that we want to write down the given information. So, what they have given, right? So, we want to write down. So, it is given that x is equal to x of t. What it means? Denote the position of the mass, or I can say that position of m at time t, right. So, then we know the spring equation. So far we have discussed about the spring equation. I can use the spring equation, d square x upon dt square is equal to minus times of omega square x, with omega is equal to square root of k by m, where k is the spring constant and m is the mass. Is it clear? Right. And they have given all those values. Now, you want to write, right, since k is equal to 3 by 2 and m is equal to, means mass is equal to 1, omega is equal to square root of 3 by 2. At time t is equal to 0, m is extended by a distance of 1 centimeter and moving at a velocity of 2 centimeter per second. Is it clear? So, it means it can be written as x naught is equal to 1 and v naught is equal to 2. Is it clear? Now, all these information given at the hypothesis of the problem, right. So, now we have all information we need to solve the spring equation or differential equation. Is it clear? Right. So, it is just like an initial value problem, right. So, you can rewrite it as d square x upon dt square minus omega square x with omega is equal to square root of k by m, where k is the spring constant, m is the mass. Is it clear? Right. Satisfying x is equal to 1 and dx by dt is equal to 2 when t is equal to 0. Is it clear? Right. So, it is an our initial value problem, right. Now, how we are going to solve this equation? As usual, right. So, you can find out an symbolic form of the given equation or this equation. Is it clear? Simply replace d by dt by capital D. It can be written as d square x, right, plus omega square x is equal to 0, or x is common, you can take out. So, what you will get? D square plus omega square into x. Is it clear? Right. Then replace d by an variable m. Is it clear? Right. So, then you will get an auxiliary equation. So, from that you can find out the roots. Is it clear? Right. I hope you can obtain the roots. Here you will get a square root of 3 by 2. It means once again you will get a complex roots, right. So, from the roots you are able to write down the solution. How we are going to write down solution? X of t is equal to a into cos of square root of 3 by 2 t plus b into sine of square root of 3 by 2 into t. Is it clear? Again, by using principal superposition principle, we are able to write down in this form, right. So, now they have given initial conditions. By using the initial conditions, as usual, you can find out the value of a and b. Here a and b are arbitrary constants, right. So, using the conditions we obtain a is equal to 1. So, b is equal to 2 divided by square root of 3 by 2. Then I can replace a by its value, b by its value. So, finally, I can obtain the particular solution. X of t is equal to cos of square root of 3 by 2 t plus 2 divided by square root of 3 by 2 into sine of square root of 3 by 2 t. Is it clear? Right. So, I have already solved similar type of examples. That is why I have written directly. I hope it is follows. Okay. Now, according to the requirement, we want to calculate 1 by 1. So, what they have asked, how fast is m moving? It means mass is moving at t is equal to 3. How do we calculate? It is very simple, right. They have given d square x upon dt square is equal to omega square x. Is it clear? Right. Where omega is equal to square root of minus k by m, where k is the spring constant and m is the mass. Okay. Now you can obtain the derivative of the solution. Just now we have obtained, you can obtain the derivative of that function. I hope you will get x single prime of t is equal to minus times of square root of 3 by 2 into sine of 3 by 2 t plus 2 times of cos of square root of 3 by 2 t. Is it clear? Right? You can in this equation replace t by 3. So what you will get, x single prime of 3, right, constant I will write as it is, sine as it is, right. Here t is there, I will replace 3 by t by 3. Is it clear? Plus 2 times of cos of 3 times of square root of 3 by 2, right. Why? Because I am replacing t by 3. Is it clear? And I have to simplify approximately. I hope you can calculate by using calculator or using any other media. I am able to calculate cosine of these values and sine of these values, and after simplification, so finally you will get minus times of 1.1 centimeter per second, right. And you observe the negative sign, right. So negative velocity represents upward motion. I think in the last session I have mentioned why it is a negative sign while discussing about Hooke's law. Is it clear? Right? Here we have obtained a negative sign. It indicates that velocity represents upward motion. Is it clear? Right? So exactly in the similar way, now you want to calculate second part. Right? So what is the second part? What is m's acceleration at t is equal to 4, right. So now I want to calculate acceleration. We know that acceleration means we can calculate second derivative. Is it clear? Alright. Now just now I have obtained the first derivative of the solution, right. So now I want to differentiate this equation one more time. Is it clear? Now how we are going to calculate x double prime of t is equal to d by dt of, I have written the same thing, right, and it is treated as a constant derivative of sine t. It is just like sine t, or it is just like sine a into t. Is it clear? Right. So minus times of 3 by 2 cos of at. Is it clear? Right. How we will get to 3 by 2? So because square root of 3 by 2 into square root of 3 by 2, I hope we can obtain 3 by 2 negative sign as it is. Is it clear? Right. So minus 2 times of sine of t into square root of 3 by 2, because the derivative of it is just like cos at, right. So derivative of cos at is a into sine of at along with the negative sign. Is it clear? So like that, I hope we are able to find out the derivative of this function, and finally I can obtain second derivative, right. And thus the acceleration at t is equal to 4 is, right, because they have asked us to calculate what is the acceleration of the mass when t is equal to 4, right. Just now we have obtained second derivative of the solution. It is very simple. This equation containing t, is it clear, right. So now I want to replace t by 4, right. So wherever t is there, simply replace t by 4, right. I hope you can obtain this type of equation. X double prime of 4 is equal to minus times of 3 by 2 cos of 4 into square root of 3 by 2. Is it clear? Minus square root of 6 into sine of 4 times of square root of 3 by 2. Is it clear? Now as usual you can simplify. I hope you will get 2.13 centimeter per second square. Is it clear? So like that we have obtained an acceleration when t is equal to 4, right. Along with this, they have also asked us to calculate what is m's maximum displacement from the rest position when it does occur. So we have to calculate, right. How do we calculate? So you know the solution, right, and we have obtained first and second derivative. From that we have obtained velocity and acceleration, right. And third one is the simplest way to find maximum displacement is to use the phase amplitude. Is it clear, right. So yesterday in one problem I have already discussed, right. Solution can be written down in this form, right. So, alpha into cos of omega t minus theta, that is equal to alpha into cos omega t cos theta plus alpha into sin omega t sin theta. Is it clear? It means this can be written in this form. Yesterday I have shown how we are going to write down in this form, right. The maximum displacement in the amplitude is alpha is equal to square root of a square plus b square, where a and b are the coefficients of sine and cosine in the solution. Is it clear? Right. So, we know a and b, a is equal to 1, b is equal to 2 divided by square root of 3 by 2. So, alpha square is equal to, I will calculate alpha using the formula 1 plus 8 by 3, that is equal to say 11 by 3, or you will get square root of 11 by 3, or you can obtain the value of alpha 1.91 centimeters. Is it clear? Right. So, which is a little lesser than twice the initial displacement, right. So, like that you can calculate a displacement or when it attains. Exactly in the similar way we want to draw the diagram of the curve. So, because last part of the equation or given problem is they have asked us to draw the diagram. Is it clear? How we are going to draw the diagram, we will come to know, right. To sketch a graph we also need the phase shift, right. So, theta is equal to tan inverse of b by a, as I have mentioned earlier, right. So, which is the first quadrant, since a and b are positive. Is it clear? Thus, theta is equal to tan inverse of 2 divided by square root of 3 by 2. You know the values of a and b, we can substitute and we can simplify. Approximately you will get 1.02, right. And so, the maximum point on the graph occurs at theta divided by omega, or that is equal to 1.02 divided by square root of 3 by 2, approximately 0.83, right. The period is 2 pi by omega, that is equal to 5.13. It means you can calculate frequency as well as period. Is it clear? So, like that we are able to find out a, b, c, d, and we can draw the graph. Is it clear? Right. This is the solution curve, right. When you type the equation, I hope you will get a curve like this, and you can calculate amplitude and you can calculate period from one point to another point. Okay, right. A differential equation of free damped motion. Friends, so far we have observed in the differential equation, right, only two terms. Is it clear? Right. So, now I want to introduce one more term, right, namely, so this term. So far we have seen only two terms. In the earlier examples, it is given that d square x upon dt square plus omega square x is equal to 0, or d square x upon dt square minus omega square x is equal to 0. Is it clear? Right. So, instead of two terms, suppose if we introduce one more term like this, what happens, right? We will observe. Is it clear? Or the same differential equation can be write down in this form, d square x upon dt square minus 2 lambda into dx by dt plus omega square x is equal to 0, right. So, simply I have replaced beta by m by another constant, say 2 lambda, and omega square by k by m. It means I have replaced k by m by omega square. Is it clear? Right. Then this equation can be rewritten as, right, or you can write m square plus 2 lambda m plus omega square is equal to 0, and it becomes an algebraic equation because I have replaced a capital D by a small m. Is it clear? Right. And we know that it is a second degree equation. Is it clear? Right. So, you know the formula, quadratic formula. By using a quadratic formula, we are able to calculate the values of m. right. I hope you will get two values, because the it is a second degree polynomial, right. Namely, I can obtain m1 and m2, right. So, I hope you will get complex roots, right, or you will get roots like this minus times of lambda plus square root of lambda square minus omega square. M2 is equal to minus lambda minus square root of lambda square omega square. Is it clear? Right. So, we can now distinguish three possible cases. Is it clear? Depending on the algebraic sign of lambda square omega square. It means, so we have to think whether lambda square omega square is equal to 0, may be equal to 0, may not be equal to 0. May not be equal to 0 means I have to think whether it is greater than 0 or less than 0, right. So, suppose if it is greater than 0, then I have to think what type of roots I will get. I have already explained, right. So, if it is less than 0, what type of roots I will get, I have to think. Is it clear, right. So, sometimes may be equal to 0, then what type of roots we will get, right. So, we have already discussed all these cases. Is it clear, right. So, now you may think about since each of the solution contains damping factor, right. So, e to the power minus times of lambda t is an very important factor in the solution. Is it clear? We call it as it is a damping factor when lambda is greater than 0, right. The displace, right. So, the displacements of mass become negligible over the long period of time. Is it clear? So, it means as t increases, right, as t increases, t means what? Time increases, displacement is negligible, right. So, it means displacement becomes almost 0, that is the meaning, right. Now, we can take case by case as I have mentioned, right. So, we have to think about lambda square minus omega square, right, whether it is positive or negative or may be equal to 0, right. So, now I will consider it as an lambda square minus omega square is greater than 0. Is it clear? In that case, what type of roots we will obtain? We are already familiar, right. Still I want to repeat once again. In this situation, the system is said to be over damped, right. So, I will call it as an over damped because the damping coefficient beta, right, is large when compared to the spring constant k. Is it clear, right. So, our differential equation containing beta as well as k, right. So, you can replace beta by some constant, k by some constant, and we have to think whether beta is larger than k or not. Suppose if beta is larger when compared to the spring constant k, in that case, so we can say that over damped motion or motion is called over damped motion. Is it clear, right. So, mathematically we know that in this case we will get roots, right. So, what type of roots we will get? So, you will get two real and different roots. Is it clear? Namely m1 and m2. Is it clear, right. I hope we shall find out two roots, namely m1 and m2, right. So, according to the given equation, so we are able to write down. So, x of t is equal to e to the power lambda t into c1 e to the power square root of lambda square minus omega square. Is it clear? Because in the earlier slide I have mentioned, right. So, we may obtain a roots like this, right. So, minus times of lambda plus square root of lambda square minus omega square. According to this, I can write down a solution in this form, c1 into e to the power, right, into t plus c2 into e to the power minus times of lambda square minus omega square into t, right. So, roots are real and distinct. Is it clear, right. The equation represents a smooth and non-oscillatory motion. Is it clear? Right? Suppose if the roots are real and different, right? So you will get a smooth curve like this. Is it clear? So we call it as an non-oscillatory motion, right? Is it clear? You may get a smooth curve like this, or you may get a similar type of curve. Is it clear? Right? From say for example, if you take this position is the equilibrium position. Is it clear? Right? So you may get curve like this. Is it clear? It is a non-oscillatory curve. It means sometimes it may not crosses the t-axis. Is it clear? Or you may get curve like this from the from below the equilibrium position. Is it clear? Right? So curve you will get a smooth curve like this, and it may not crosses this axis either from upward direction or from the downward direction. Is it clear? Right? Now, if possible, in the next session I will show you, right, how a curve will move along with the spring motion. Is it clear? Right? Sometimes we call it as an over damped, right? So solve an initial value problem, d square x upon dt square plus 5 times of dx by dt plus 4x is equal to 0, right? So assume that, or we know that we have introduced one term, namely 5 into dx by dt. In our earlier examples, this term was not there, right? And along with this differential equation, they have given an initial condition, x of 0 is equal to 1, x of single prime of 0 is equal to 1, right? So friends, as usual, you can write down in symbolic form, right? Symbolic form means it is very simple. You can replace d by dt by capital D. Is it clear? I hope you will get d square x plus 5 times of capital D into x plus 4 into x is equal to 0. All the terms containing x, you can take out x. Is it clear? And in the remaining part, it means coefficient of x, right? It is a polynomial in capital D. Is it clear? Right? I will replace capital D by m, right? So what we can obtain? We can obtain m square plus 5m plus 4 is equal to 0, or this algebraic equation can be write down in terms of factors. Is it clear? Namely, you will get m plus 1 into m plus 4 is equal to 0. Is it clear? So therefore, m1 is equal to minus 1, m2 is equal to minus 4. So how we will get? How we will get from these two factors? It is just like a into b is equal to 0. Either a is equal to 0 or b is equal to 0. Is it clear? Right? Suppose if I write m plus 1 is equal to 0, therefore m is equal to minus 1, and another possibility is m plus 4 is equal to 0, therefore m is equal to minus 4. Like that you can obtain these two roots. You observe the roots, roots are real and unequal mathematically. Is it clear? Right? I hope we are able to write down the solution. Solution is x of t is equal to c1 e to the power minus 1 into t plus c2 into e to the power minus 4 into t. Is it clear? And they have given the initial conditions. Now I am going to use an initial condition, x of 0 is equal to 1, and I can find out the arbitrary constant. I will get an equation c1 plus c2 is equal to 1. So you may call it as an equation number 1. Is it clear? Right? So you can differentiate the solution, right? I hope you will get x single prime of t is equal to, right? So minus times of c1 e to the power minus 1 into t minus 4 into c2 of e to the power minus 4t. Is it clear? And they have given one more condition. We can use that condition. We can find out another equation. So now we want to solve these two equations, right? So by solving these two equations, we can obtain the arbitrary constants in the usual manner. C2 is equal to minus 2 by 3 and C1 is equal to 5 by 3, right? And I can substitute these values in the solution, right? I will replace C1 by 5 by 3, C2 by minus 5 by 3. Is it clear? So I will get the particular solution, right? So when you draw the graph, I hope a graph will get in this form. What is the meaning of this graph? The problem can be interpreted as representing the overdamped motion of a mass on spring. The mass starts from the position 1 unit, right, 1 unit below the equilibrium position with the downward velocity of 1 feet per second. Is it clear? So, that is the meaning of this graph, right. So, friends, exactly in the similar way, or if it is possible, I will show you the same thing using an software like GeoGebra in the next session. So, thank you very much.